Everyone on Earth has seen a falling star or shooting star. As a child, I genuinely thought these were stars, just as I believed in Santa Claus. But later, I discovered the shocking truth. These aren't stars. Looking into the night sky, I've watched countless meteors try to penetrate Earth's atmosphere. This happens constantly, with millions of cosmic bodies hitting our planet daily. There's nothing extraordinary about it. However, despite the absurdity of the phrase, "Look, a falling star," real falling stars do exist in our universe. Hello, and welcome to ZE. Please don't forget to subscribe and hit the bell icon. Buckle up, everyone. We're heading into deep space again. Meet Mira, also known as Omicron Ceti, a star 700 times larger than our sun's diameter. It's even stranger and more surprising than Betelgeuse, the star from our last episode. Mira was first mentioned by Hipparchus in 134 BC and by Chinese astronomers in 1070. However, its supernatural properties were only discovered recently. Pastor and astronomer David Fabricius accidentally discovered a new type of star on August 13, 1596. He was observing Mercury to measure its distance from a nearby star with an apparent magnitude of 3 in the Cetus constellation. Surprisingly, he had never noticed it before, and it wasn't on any stellar maps or globes. Despite the inaccuracies of old maps, the neglect of dim stars was common. Fabricius observed the star, and its brightness grew to a magnitude of 2, becoming the brightest star in its constellation by the end of August. But by mid-October, the star faded and disappeared. Believing it was a different star, Fabricius stopped observing. But 13 years later, on February 15, 1609, he saw it again. Johann Bayer had noticed it 6 years earlier, in 1603, and recorded it in his star atlas, though he hadn't realized its unique properties. By then, the star had a magnitude of 4. Various astronomers worldwide monitored Omicron Ceti for decades. Polish astronomer Jan Hewelius, who observed it from 1659 to 1682, named it Mira, Latin for amazing. And he was right. This star is amazing. Usually, Mira is so dim that it's hard to see even with a small amateur telescope. But due to its peculiarities, it becomes the brightest star in Cetus at certain times. Then it fades and becomes nearly invisible, repeating this cycle. By the mid-17th century, scientists found that this miracle was a new type of variable star with a long brightness period and large amplitude. Mira's brightness changes irregularly. Its apparent magnitude fluctuates, with smaller numbers indicating brighter stars. Mira's brightness increases 3.5 times in 332 days, from a magnitude of 10, nearly invisible, to a magnitude of 2, brightest in its constellation. There's no pattern to its behavior. Its period and brightness range are unstable. Sometimes it goes from the 9th to the 5th magnitude, and other times from the 10th to the 2nd. These fluctuations in luminosity are immense. What does this mean? At its minimum brightness, Mira's luminosity is almost equal to or slightly less than our sun's. At its maximum, Mira's brightness surpasses our sun's by 700 to 1,500 times. This is because when red giants pulsate, their surface temperature changes, affecting the stellar atmosphere's optical properties. As the temperature rises, chemical compounds decompose, making the atmosphere more transparent. Hot hydrogen masses also erupt during maximum brightness, further increasing the star's brightness. This is the most plausible explanation for Mira's regular changes. There's more. In 1919, scientists noticed a second spectrum superimposed on Mira's, belonging to a very hot white star. A satellite was discovered close to Mira 4 years later, a white dwarf called Mira B, which feeds on its larger neighbor. Mira B orbits the giant Mira once every 400 years, having completed one revolution since Fabricius's time. The average distance between them is 70 astronomical units, or 70 times the Earth-Sun distance. Interestingly, the dwarf star has similar properties to its larger friend. The white dwarf also changes its brightness regularly, but for different reasons. Mira B has an accretion disk, interacting with the main star and drawing stellar matter. Due to the uneven supply of this matter, the dwarf's luminosity changes, ranging from magnitude 12 to 9.5. Measuring changes in brightness in stars like this involves extensive astronomical work. To obtain a star's luminosity fluctuations over 13 years, scientists must account for and overlay all brightness changes and their durations, measured in minutes. Finally, some fascinating tidbits. The Galaxy Evolution Explorer, GALEX, satellite, an ultraviolet space telescope launched in 2003, discovered a tail of matter stripped from Mira A, like a comet's tail. This gigantic tail is about 13 light-years long. To grasp this distance, the nearest star to our Sun is about 4 light-years away. Most stars in our galaxy rotate around its center at similar speeds and directions as interstellar gas. In contrast, Mira moves through galactic gas clouds at 130 kilometers per second, creating a bow wave tail of compressed gas. Every 10 years, the star loses a mass equivalent to Earth's, forming a tail over 30,000 years. I'd love to see this up close, but only a god could. A huge swelling in front of the star, visible in GALEX's pictures, is the shock wave region, similar to the wave formed in front of a speeding boat or bullet. The universe is a vast expanse filled with an array of celestial wonders, from blazing quasars to enigmatic black holes. Among these, stars hold a special place, being the fundamental building blocks of galaxies. While many stars follow predictable life cycles, some defy expectations with their bizarre and mysterious characteristics. One such star that stands out as the strangest in the universe is the magnetar, specifically SGR 1806-20. This star challenges our understanding of astrophysics and offers a glimpse into the extraordinary forces at play in the cosmos. What is a magnetar? A magnetar is a type of neutron star, the remnants of massive stars that have exploded in supernovae. Neutron stars are incredibly dense, with a mass greater than that of the Sun compressed into a sphere just about 20 kilometers in diameter. Magnetars take this a step further, possessing magnetic fields 1,000 times stronger than those of typical neutron stars. These magnetic fields are so intense that they can distort the shapes of atoms and generate radiation of unimaginable power. SGR 1806-20, a cosmic oddity. SGR 1806-20, located about 50,000 light-years away in the constellation of Sagittarius, is the most powerful magnetar ever discovered. This star has a magnetic field strength of approximately 10 to the power of 15 Gauss, making it the most magnetic object known in the universe. To put this into perspective, Earth's magnetic field is a mere 0.5 Gauss, and even the strongest magnets on Earth reach only a few tens of thousands of Gauss. The burst of 2004. What truly sets SGR 1806-20 apart is the extraordinary event that occurred on December 27, 2004. On this day, the magnetar emitted a colossal burst of gamma rays, releasing more energy in a tenth of a second than the Sun emits in 150,000 years. This burst was so powerful that it affected Earth's ionosphere, even though the magnetar is located halfway across the galaxy. The event was detected by satellites and ground-based observatories, marking it as one of the most significant astronomical events of the 21st century. The science behind the strangeness. The intense magnetic fields of magnetars are thought to arise from the rapid rotation and high energy of the neutron star. These fields can cause the crust of the star to crack and shift, leading to starquakes. These starquakes, in turn, can release enormous amounts of energy in the form of gamma-ray bursts. The exact mechanisms behind these processes are still not fully understood, making magnetars like SGR 1806-20 subjects of ongoing research. The implications for astrophysics. The study of magnetars has profound implications for our understanding of the universe. They provide insight into the behavior of matter under extreme conditions, the nature of magnetic fields, and the life cycles of stars. The existence of such objects challenges existing models and prompts scientists to develop new theories to explain their formation and behavior. Furthermore, the energy released by magnetars could potentially influence the dynamics of their surrounding regions, affecting the formation of stars and the evolution of galaxies. Conclusion: the universe is a treasure trove of wonders, and SGR 1806-20 stands out as one of its most intriguing and enigmatic inhabitants. As the strangest star known to humanity, it not only captures the imagination but also drives scientific inquiry into the fundamental laws of nature. The study of such extraordinary objects reminds us of the vastness and complexity of the cosmos and our ongoing quest to understand it. As we continue to explore and learn, stars like SGR 1806-20 will undoubtedly remain at the forefront of astronomical research, offering new mysteries and discoveries along the way. In conclusion, we've discovered over 46,000 variable stars in the Milky Way and about 10,000 in other galaxies, with more found every year. Please like or dislike, subscribe, and share with friends and well-behaved acquaintances. Until next time,